Welcome, everyone. My name is Jason Von Ruden, and I'm the president of the Wisconsin.NET User Group. And we have monthly meetings that cover the latest technologies, including web, mobile, cloud, .NET, and more. Thanks for being here. I also have a few announcements of upcoming events. Next month, there's no meeting, but we have a meeting scheduled in January to talk about some .NET 7 things, so stay tuned for that. Today, we have a talk on building your .NET services using gRPC with Alex. Forgive me if I get the name right. Ryazhnov? Yeah, perfect. Thank you. Please welcome Alex. We'll have an awesome talk. At this point, I'm ready to take it away.
Right. Yeah, so I'm Alex Ryazhnov. I'm a staff software engineer at Mastery Logistics Systems, and I've been doing .NET for more than 12 years now. And in this talk, we'll be taking a look at gRPC, how to set this up in .NET, and also we'll take a look at why gRPC might be preferable over RESTful services. So we can start with an introduction of gRPC. So when doing distributed computing, we have to choose a communication protocol for our APIs. And there are a few primary architectures: SOAP, REST, or representational state transfer, GraphQL, or the gRPC focus of this talk. So what is gRPC? gRPC stands for gRPC Remote Procedure Call. And to quote gRPC.io, gRPC is a modern, open source, high performance remote procedure call framework that can run in any environment. It was released in Google in 2016, so it's pretty new technology. And some of the early adopters of gRPC include Square, Netflix, Cisco, and Juniper Networks. It is contract-based. It requires you to have a defined contract in order to set this up. It uses HTTP2 for transport and protocol buffers as the interface definition language. And gRPC calls are made with binary communication. It supports client, server, and bidirectional streaming, and that's what sets it apart from the REST. So gRPC is based on the idea of defining the service contract first. So in this example here, we see the .proto file, which defines the service contract. So we have a greeter service and the single action, say hello. And then we have the models defined for the action. And to use the protocol buffer to compile this service definition into the actual code. And we can use the different languages for compiling. So in this case, we have the C++ server and the Ruby and Java clients. So like I mentioned, gRPC uses protocol buffers for describing both the service interface and the structure of the messages. So what is it? It's the interface definition language created and released by Google in 2008. It is language independent, it's fast and efficient, and messages are very small compared to JSON. Its key feature is that it's using the binary format instead of the string-based format, and it separates context and data. So on a typical message with protocol buffers, you will not see the actual field name. You would just see the number, and I'll show you later what it looks like. So this is the workflow for setting up the service with gRPC. So we first have to have a defined service contract in that proto file with a service definition and data structure. And then we'll use the proto-C compiler to compile this in code of our choice. And there's multiple supported languages. And then this code can be used to actually set up your projects with a server or the client, and then serialize or deserialize data. And then you can find more information on this link. So let's talk about the differences with gRPC versus REST. With gRPC, we have to have a defined service contract, and with the REST, we don't have to have a contract. There's optional. We can use the open API, but you don't have to have it. And with REST, we are manipulating resources with get, post, put, and delete. But with gRPC, it's action-based. It's more like a function-based, so it doesn't have those verbs. And gRPC is tight coupled, so you have to have a service definition in order to set up your service. And service and client have to implement the same service definition in order to communicate to each other, whereas REST is loosely coupled. So gRPC is done over HTTP2, and REST is typically HTTP1. Message format is protocol buffers and JSON for REST. And REST follows the request response model, whereas gRPC is a request response, and it does have a strong streaming support. gRPC has a native code generation using Proto-C compiler. In REST, you have to use the third-party tools for code generation. So what are some of the strengths for gRPC? It's fast. It provides the performance benefit because it uses HTTP2. The messages are very small compared to JSON, so it's very efficient in serializing the messages. It has a native code generation in multiple languages, and it has a first-class streaming support. Those strengths make it a good candidate for use in microservice environments, including multi-language environments for efficient service-to-service communication. So if you're looking to set up your services in multiple languages and you're looking to set up the service-to-service communication, I think gRPC would be a good choice. It also has its use in limited bandwidth scenarios such as mobile apps because the messages are very small. But it does have its own limitations. So messages are not human readable, and it has limited browser support. If you're taking a look at the gRPC message coming over the wire, it actually looks very cryptic, whereas JSON, you can just read it. So with it will require gRPC web and proxy layer to be used in browser apps. So it's not easy to set up in browser scenarios. For that reason, REST API is still probably a better choice for dealing with browser apps. And with that, we have a demo. I'll show you, this is the demo plan. So I'll show you how to set this up in ASP.NET Core application. And we'll start with a employee REST API .NET Core app. Then we'll add the gRPC server in the same application. Then we'll set up the client to consume the employee API that we set up. Then we'll add the streaming endpoints and set up the middleware and interceptors. And we'll add the security. So I'll flip to Visual Studio. So what we have right now is we have the gRPC.NET demo server. It's the ASP.NET application with a controller. This is just the regular ASP, RESTful controller with the get, post, put, and delete on employee resource. Then we have the contracts project, which is just the REST contracts. And then the client is the console app, which is used to invoke the our server. So if I run it, it's just the so we have the Swagger contract for RESTful API endpoints, and this is just the regular REST API endpoints. So we'll convert those REST endpoints. I'll just have them side by side with our gRPC service. So in order to set up the gRPC server, we have to have a defined service interface and payload messages in that proto file. And once we have our defined contract, then we can use the gRPC.tools package to actually compile this into our C# code. And then we'll have to implement the gRPC service in .NET Core. And for that, we have to override the generated gRPC service-based methods. Then we'll have to register this in our application, and we have to set up the cast shell with HTTP2. Right. So here I'm showing you the .proto file with a defined contract, and as you see here, there's the service definition with actions. So there's the RPC keyword, which represents the action for each action in the service. Then we have the models specified over here, the return type. This option here will tell us what namespace to put the generated code in. This is just for C#, but there's actually other options for other languages. Import statement is just like the C# using. So in this case, we are importing the Google protobuf timestamp, and timestamp is a way to have the date time defined in a contract over here, because there's no concept of date time in .proto file. So just to show you an example of the message payload here, like a message payload, we define the model with a message keyword, and then we have the string type for the employee ID field. Then there's the timestamp. Repeated represents the list of things. So if you want to have a list of skills, for example, you would have to say repeated. And the actual number here is not an assignment. It represents the where the field is going to be put in the message. So where you saw the with a JSON, you have you would have like employee, then the employee ID field. But with protocol buffers, you would have this field represented as one. So your message would look something like this, where you would have like a field number, then the length of the field, and then the actual field value. So it would be a lot smaller to compare to JSON. And I added the gRPC.ASP.NET Core reference for this. And there's actually gRPC.tools packages, which I mentioned, which generates the code in the C# code. And this line here is what's generated in our classes. So as you see here, we have the employee management service generated by the protocol buffer compiler. So as you can see, there's like a lot of code in it, and it looks very cryptic. And we don't touch this; it's just generated by the protocol buffer. So if we go back to here, so there's few different options we can specify, but the important one here is the gRPC services. And for this, we can have few different options. There is a server option. Server option would generate just the server code and the models. Then there's a client option. This would generate the client code and the models, but not the server code. There's the both option, which would generate both the server and the client and the models. And there's a none option, which means that the only models will be generated, no servers or the client code. So if I actually save this, let's remove this right now. So as you see, like the employee management service popped up. This is generated from the CS project file. And this is just the models over here. Then if you look back and say server, you can see the employee management service gRPC is popping up over here. This is the server code. this is what we would use to set up our endpoints in the API project. So if you go back to the server, now we have the employee gRPC service class, and this will be added manually. This is not something that the protocol buffer would generate. Protocol buffer just generates those classes here. So this one is added manually, but we have to inherit from the generated class. So this is the employee management service base. If you go to that, it will take us to the generated code from protocol buffers. And then in here, as you see, we are overriding the actions. So get employees, get employee, create employee. And this is the actual gRPC model. Again, this is generated. And then there's a service call context, which is kind of similar to HTTP context, but it's a gRPC level of abstraction. So it provides us more details on gRPC calls being made. So with that, if you compare it to the controller with the REST endpoints, you can see the difference here. So with REST, we have to define the verb, HTTP verb. You have to define where the model is coming from body or from query. The API controller here, inheriting from controller base, but with gRPC, it's the generated gRPC class, and there's no verbs here. Okay, so if we go to startup.cs, we have to add the add gRPC, use the add gRPC extension to register our gRPC, and we have to map gRPC service with the endpoints. And then we have to configure the Kestrel using HTTP2. So with that, our service would be running in our regular ASP.NET Core RESTful service. So our endpoints would be available. Right. So the next step would be to set up the client in order to call our service. So for the client, it's a similar process. We have to use the Proto-C compiler to generate client code. And we can actually use the add service reference to find the proto file. So it can either use the URL option or the file option, or we can just generate those files using our gRPC tools package and include this in the project. Then we have to use the gRPC channel.for address to create a channel. This will represent our connection to gRPC service. And it's a long-lived connection, so you don't want to recreate this every time you want to make a call. It should be reused across the gRPC calls. And then we have to create a client that uses that channel to make calls, and this client can be recreated multiple times. So let's see what it looks like, the client implemented. All right, so in here, actually did something different. I set up the gRPC services none option, which would generate just the models. But then on the next line, there's the gRPC services both option, which would generate the corresponding server code and the client code. And this would allow us to split this in two different files. So there's the employee models file, which is just the models. And then there's the client code and the server code over here. So if you search for the client, we now have the employee management service client. And then in our client side, so we are setting up the gRPC channel for address. We are providing the URL for the gRPC service. Then there's the gRPC channel options, which can be used to customize the way that the call is done. So this is the channel that we're creating just once. And then here we are using the channel to create our client. So this is the employee management service client, which is the generated from the protocol buffers file, and it's using the channel that we set up. Right. So if now let's add a breakpoint on our gRPC service. Let's see it being hit. Right. So this is just the console app to call our service. So I can do gRPC create. We're still on the client side. This is calling the create method, and then we are seeing our employee gRPC service being called right now. So this is what we had set up previously with the gRPC service, service call context, and our request, which came in. And from that point on, it's just regular C# code. The rest of this was serialized, deserialized using the gRPC libraries. Right, so let's talk about streaming. So the streaming is something that sets gRPC apart, and that's what I like most about gRPC. So with a gRPC, there is a few different ways to set up streaming. There's a server, client, and duplex or bidirectional streaming. With a server, the client is sending a request message just once, and the server is streaming messages back to the client. With a client, it's the other way around. It's the client that's streaming messages to the server, and the server responds with a single message. And one important thing to remember about client streaming is that we have to call the completed sync on the client side. Otherwise, the server will not be able to tell when the streaming is done. So we have to call the completed sync. And with a duplex, it's it's a combination of the two. So it's a client and server streaming messages to each other. It's kind of like they're talking to each other basically. And streams are independent, so messages can be read and written in any order. And I'll show you what it looks like. All right, so if we go back to our proto file, so I actually split this up in two different files. This is the model file, and the servers file is a separate proto file. So right here, I added three streaming options: server, client, and the bidirectional. So what's different from the other calls is that stream keyword, which indicates what we are streaming. So with the server streaming, we are streaming the response from the server, and with the client, we are streaming the request from the client. With the bidirectional, we are streaming both ways. Maybe take a look at the employee gRPC service again. Actually, let's look this side by side with the client. So this is our server. And the client. All right. So this is the client side on the left and the server side on the right. So with the server streaming, we are using our generated code to actually set up the streaming call, and then we have the response stream object, and we are writing the we are moving on the objects from the response stream with the server streaming. So if you take a look on the right, on the server side, we are writing to the response stream object individual employees. So this is the response stream, and we are writing the objects to it, and then we are accessing this in while loop. So once this is done, then move next would indicate that it's completed, and it would exit out of the while loop. So the client streaming is more complex because we have to have the complete async call. So in this case, we are setting up our call, and then we have the request stream object, and we are writing the objects from the client, and then calling the complete async once we are done writing the client objects. And on the server side, so there's the request stream instead of the response stream, and we are just iterating over the request stream for the objects coming in from the client. And then once the complete async is called, then we'll know that this needs to exit, and it would return the response back, and that's where we'll see the response over here on this line. And then there's the bidirectional streaming. Okay, so with bidirectional streaming, it's a combination of the both again. So we have both the request stream and the response stream objects, and we are reading the responses from the server and writing the objects to the request stream on the client side. And then we do have to have a complete async again in order to indicate to the server that the client is done sending the messages. And on the server side, we have the while loop again for the request stream, and then we have the response stream to write our messages back to the client. And what's interesting about this is like it's asynchronous code, so like you don't actually have the defined order of the messages that are coming in. So like if you're sending 10 messages from this side, you're not expecting to receive them messages 1 through 10 in order. They might come in different places, and I can show you what it looks like. So if I do gRPC messages, so in this case they came in the same order, but keep doing this. So like the second time they actually so like they came in, like messages 1 and 2 came in, then the server responded with a message back to the client. Then again 2 messages came in, it responded back with another message. So as you see here, this is like the order is not guaranteed. Right. So the next thing we want to talk about is the middleware and gRPC interceptors. So with gRPC being like done over the HTTP2, it actually uses the same middleware as the RESTful services. So all the middleware that you specify for regular HTTP calls would run for gRPC as well. But it does not have the access to the deserialized gRPC message. So if you're looking to read the actual message in middleware, you will not be able to do it in the middleware. You will have to have the gRPC interceptor, which operates on a level of abstraction of gRPC. So it does have access to the deserialized message. And interceptors do run after middleware. So the order of this is important. And the interceptors can be configured for both client and the server. So on the client side, the interceptors can be used for something like setting up the authentication. On the server side, it can be used for like reading messages or anything else that you want to do, just like with middleware. And you can set up the multiple interceptors on the client and server side as well. So I'll flip to the interceptors and middleware. And for interceptors and middleware, there's nothing that we need to do to the protocol buffers file, because this is kind of like a C# concept, ASP.NET Core concept. I'm sure like in other languages it's using something else too. Right, so for middleware, so this is the middleware that we are setting up for gRPC, and take a note of the content type here. So any gRPC call that you're receiving would have this as the content type, application/gRPC, instead of the application/JSON. And then we'll try to read the body and see what it looks like. So with the interceptor, yeah, so like we don't actually have the access to the actual object that you're sending with the gRPC. But with interceptors, you're inheriting from the interceptor class from gRPC, and then you're overriding the unary server handler, which is just a regular action method. And then for the streaming options, there's a different streaming overrides. So the client streaming override, server streaming, and the duplex streaming. So in this case, we do actually have the request object coming in as a regular C# code. So we can actually read the actual message being sent here. And then in order to register this, you have to go to startup. So the middleware is registered just like any other middleware. Use middleware here. And for interceptors is the gRPC, and that is the options.interceptors.add here. And then just like you can actually chain the interceptors here, multiple interceptors. On the client side, you can still set up the interceptor as well. So this would be similar. This is the request, and you can read the response as well from on the client side before it gets to your client code. So let's set up breakpoints on here. The interesting thing is to check out is like this part here, login middleware. Right, so it's hitting our login middleware over here on our server side. Content type is going to be application/gRPC. And if you read the body, so this is the raw gRPC message body, and it's looking very cryptic, as you see here. So this is like what I mentioned before. It actually has like the number of the field, then the value, number, the length of the field, and then the value. And it would be different from with like some other types. So you will not be able to read this without gRPC abstraction. But if we hit the actual gRPC interceptor, we can see that the request is coming in over here, and it's able to deserialize this into C#. So we are able to access the actual object here, first name, and so on. Right. So for the security, it's actually not much different from the regular ASP.NET Core application with the security. We can use the same middleware to set up the authorization and authentication. We can just decorate the gRPC service and the methods with the authorizer attribute. And on the client side, we have to attach the authorization token to the call being made to the server. Right, so for the security, I added the get token option here. And then on our employee gRPC service, there's now get token with allow anonymous access. And this one has the authorized attribute. So you will not be able to access the rest of the actions here, just the one that's allowing anonymous access. So if I run this and we try to hit it without authorization, it should error out. Yeah, so it's the returning 401. So in order to make a call now, we have to have a token. So we go back to the client code. There is now the get token option. So it's going to call our server, and then when this is returned, we are going to attach the bearer token to the headers, and these headers would be used on our on any of our calls. So that way, it would be able to authenticate. So if I do get token, gRPC.create, it should be able to make a call now. Yep, and our call succeeded. Yeah, so this is all what I had to show you for this. So this is my contact information, and you can find me on LinkedIn. And the code will be available on GitHub repo, so you can take a look and explore this on your own. And at this point, I can take any questions.
Well, thank you. That was a very good talk. If anybody has any questions, please put them in the chat and we can address them.
Oh, sorry, I didn't see your message about the font size.
No worries.
Was it really small?
It was okay. I thought it just a little bit, but being it's a screen, it should be fine.
Okay.
No worries. Okay. Well, next month there's no meeting, and then the month after, and then in January we're going to have a .NET 7 talk. So please stay tuned for that. Thank you, Alex. It's awesome.
Hey, you're welcome.
Have a good one. Bye.
Yep. Bye.